All right, our third topic today. We saw a recent article discussing the theory that it's been circulating a little bit more. It's not necessarily brand new, but just it's been circulating recently. Just the theory that our known universe, the universe, that everything that we can see, as far as we can see, and everything like that, may just be the inside of a black hole. And then conceivably that being the case, there's some bigger universe or multiverse outside of this black hole that we're in. And there could be other stuff going on there and other stuff, whether it's going on in black holes or outside of, whatever. But just that, again, the what we're living in and what we see is one of these structures that we can't see when we look out into space, but that we can see the gravity and so forth that comes from it. So Tunde, I know you're a big science fiction guy. And as we know, and when you're looking at the cutting edge of science, a lot of times in any given time, it does look and feel and sound a lot like science fiction. So there's no more cutting edge science than, hey, we all live in a black hole. So where does your sci-fi mind? Well, one, just your thoughts in general on the idea. And then two, where does your sci-fi mind go from here?
Yeah, this is, it's fascinating. I mean, to contemplate what they're saying, because, I'll quote from the article just for the audience. It says, perhaps the most notable one is that if we calculate the size of a black hole with mass and energy equal to the mass and energy we can see in the universe, we get a surprising result. It's almost the same size as the observable universe. Yeah. So the idea that, and this is where I'm a little bit confused with the article, because we have, lots of black holes in our universe. So are we saying that each one is the size of this universe, or
well, no, it's saying that basically everything that we can see based on the size, that proportionality is the same of what we estimate would be inside of a black hole as well. So it's really interesting. And then also the idea that there's a point we can't see beyond is also consistent with the idea of an event horizon in a black hole, where once something crosses that threshold, nothing can get back out again. So there are a couple of analogous kind of features that are observed from a astrophysics standpoint that would be analogous to a black hole. And so that's really the where they're coming up with this. And so it's like I said, it's interesting. It's something though we can never prove, or at least with anything close to our close approximation of science now, we can never prove. Like the only way you can really prove this is to go outside of the black hole and observe it.
Well, I'll let you know. I'm working on that. I'm going to be the first human to go into one. I'll let you know what I see.
Hey, there you go. Man.
But no, it's interesting because I've thought of that as over the years, as you learn stuff and all. Because I used to think like, okay, well, number one, what if a black hole at the other side comes out of is like a Big Bang? Because if you think about the idea of a singularity, if that based on which is already being questioned by the James Webb Telescope because of it's kind of upended the Hubble constant, this idea that everything at the same time, kind of expanded.
The Webb telescope really being the newer version that can see a lot more than Hubble telescope. These are space telescopes. They can see a lot more than the old Hubble telescope can. So
it's like but if that were to be real, it's like, all right, well, where'd that stuff come from? Well, maybe it was matter that was accumulated from some other universe and spit out and became the Big Bang, right? Like whatever the system of black holes and matter is. So who knows? That's why this is all fun and fascinating stuff. And I think the point of the James Webb, you're just describing it as good, because I think one of the things that we as human beings, sometimes either don't have patience for, or when we get new discoveries, we don't want to believe it, is, we can only know things that we can observe. So as technology continues to improve and we have a better way to observe these things, we're going to continue to learn more and more. So, maybe by the time you and I are elderly men, we'll have some of this stuff figured out. Maybe we won't, but it's
if you think of how much has been figured out, in the last 60 years or whatever, it lends to the idea that a lot of this stuff, more stuff will be figured out. But the idea of the singularity to me also creates just an interesting analogy, because you think about black holes and they come from supermassive, stars previously that ran out of fuel, collapsed on themselves, supernova, Big Bang, supernova, and then goes to a point of singularity. And it's like, well, that's what the black hole starts from. And so it's like, well, man, that sounds a lot like the Big Bang. So conceivably, it's like you end up with this kind of nesting kind of situation where there are all of these, what you could consider multiverses, that black holes basically are all multiverses. Like they're a one of them. And the ones we can see, and they're nested in our black hole conceivably. And then there's conceivably we're a black hole that's nested in some other multiverse, a larger one than ours, and we're just a single black hole in that. And then there are some in this universe, or what our known universe, that could spawn others. So it creates this nesting. It potentially creates this nesting effect that kind of a lot of this stuff when you deal with astrophysics tests your own like ability to conceive things, because even when we're talking about distance and they're like, oh yeah, this is like 300 light years away, and it's like that kind of it's easy to say that, but that kind of distance doesn't really make any sense to us, like in terms of how far it really is. It takes light billions or million years to get there and so forth. So I think with a lot of these, we really just have to appreciate it for what it is just scientific theory. And until we really have a use for the knowledge, so to speak, like, and we might, and that may be some great improvement, like the discovery of the atom, was all well and good, but it wasn't really that helpful for anybody beyond either theoretical physicists or people that are actually working to develop stuff, until you start coming up with, like nuclear power or nuclear weapons and so forth. Then the atom was like, oh, well, now we're cooking with fire, but the whole thing of like with this type of stuff, like it's good for people to theorize about this and study this and so forth, but it doesn't really mean anything for us in general, I guess, beyond the good stuff for science fiction, until we can do something with it. And so like, to me, it's just fun to kind of see, oh, well, what are they talking about now? And then kind of play it out in your mind. Or like I said, you can kind of play it out in a science fiction way like that. I'd like to see somebody do something with this in a movie now, like, well, let's see what happens, like if you play this kind of idea out.
Well, apparently in a long time ago in a galaxy far, far away, there were people thinking about this stuff. So that's why I said, I'm going to go through a black hole and figure it out. And I'll tell Chewbacca and Darth Vader you said hi.
I mean,
and I'll go find, and I'm going to get a couple of those infinity stones. They look pretty cool, but I'm not going to put them on my knuckles.
Go from black hole to black hole.
Yeah, I'm gonna like wear a bracelet, and it'll be like a Kabbalah bracelet, so that people can start the conspiracy theories. I mean, this is going to be. I'm going to create a galactic QAnon, bro. Watch out.
I guess that's the next thing we need. That'll drive more interest, is if people can come up with some conspiracy theories on, like our black hole versus other black holes and so forth. A movie that did try more recently, I know that to deal with a lot of this, was the Interstellar movie. But even still, like, it's how that took science fiction in terms of aging and different things like that, with the different things going on in space. For me, I generally wonder, and I mean, the idea, like, what would be the way, if this is being the case, like, what would be the way, or would there be a way would this allow for easier travel between galaxies within our known universe? Or even, again, what's outside? Is there a way to get outside of that? And if you get outside, could you get back in and so forth? Like, to me, there are a lot of questions that this brings up, which should be the realm of science fiction for a couple hundred years before it becomes, anything reality. But it's, I mean, at minimum, it's very interesting. And as we continue to learn more stuff, I mean, that's really what we're dealing with, is just like interesting stuff and stuff for our imaginations.
Well, the other thing, and this is how we got to drop the mic, because this will create a lot of speculation. Just like the double slit experiment, our ability to observe this stuff as it improves, will it actually change the way it functions? So will we ever really be able to know? You know what I mean? That's going to be,
yeah. I mean, like, I guess if we could get outside of this purported black hole that our known universe is in, would that change it? Like that,
correct. Because now you can.
But we got to harmonize quantum physics with regular physics first. We still haven't done that. So we like that. That's a whole nother project we got to work on. So I guess it's endless.
Well, we got a lot of work to do, but that seems like a lot of work. So I might go smoke a joint, because that seems a lot, and go watch some YouTube videos about this stuff, because that seems a little easier. I'll let someone else solve it and then watch the nice graphical documentary about
There
it.
we go. So,
So
well, no, I mean, yeah, there's no grand answer that, for this, but it's really just to kind of talk about something that seems pretty, like remarkable on its surface to think about. And, again, the more you think about it, the more like this whole nesting thing just it ends up being, like it's an endless conversation. So we'll cut it off from there. And, like we'll put the show notes in as far as just the information on that. So, but no, we appreciate everybody for joining us on this episode of Call Like I See It. Subscribe to the podcast, rate it, review it, tell us what you think, send it to a friend. Until next time, I'm James Keys.
I'm Tunde Ogunlana.
All right, we'll talk to you next time.